In this video, let us understand and resolve the common confusion among these technologies, which is duplex, multiplexing, and multiple access. We have heard these acronyms: FDD, TDD, FDM, TDM, FDMA, and TDMA. We know that the first letter in these terminologies is F stands for frequency and T stands for time. Second letter is the common among all these acronyms, which is D stands for division. Together, the first two letters convey the meaning that either frequency or time is divided into segments. But what is the significance of third and fourth letters? In case of FDD and TDD, D stands for duplex. In case of FDM and TDM, M stands for multiplexing. In case of FDMA and TDMA, MA stands for multiple access. First, let us look at the FDD and TDD acronyms. Let us understand what does this D duplex stands in FDD and TDD. By definition, duplex means an arrangement where at least there are two systems which can communicate in both directions. In case of FDD, since frequency is divided or segmented, we can imagine there are two frequency filters which allow communication to happen in either direction. Here, one frequency segment is allocated for this direction of communication and filtered by this filter, and other segment of the frequency is in the opposite direction, and this filter ensures that the communication happens in this direction. This is an FDD system. In case of TDD, since time is segmented, there is a switch which keeps switching the direction of communication in either this direction or in the opposite direction. Example of such systems are communication satellite and mobile communication. Now, let us look at the acronyms FDM and TDM. The M here stands for multiplexing. By definition, multiplexing is an arrangement where there are two related systems attempting to access a shared resource, which is either frequency or time. Here, data is coming from multiple paths and need to be sent to a single shared medium. So this shared resource can be either frequency or time over a shared medium which can be wired or wireless. In the case of FDM, since frequency is divided or segmented, there are segments of frequencies which enter the multiplexer from different data paths. Based on the multiplexer logic, the data from a particular path is chosen to be sent over a shared resource. Shared resource medium can be wired like wires or cables, or wireless like in the case of air or space communication. The data paths here pertain to a single user or a single device. Say for example, a single user could be attempting to download content and at the same time be over a audio or a video call. In case of TDD, since time is segmented, similar logic applies where a specific time segment of data is allowed to use the resource from multiple time segments entering the multiplexer. Example of such systems are communication satellite and mobile communication. Now let us look at the acronyms FDMA and TDMA. Here MA stands for multiple access. By definition, multiplexing and multiple access are not very different. Even here, like in the case of multiplexing, it is an arrangement where data is coming from multiple paths and it need to be sent over a single medium which is shared with other data paths. Just that the difference here is that the multiple data paths also represent different users or devices and hence called as two disjoint systems. These different devices or users could be from very different background, like one user trying to send video and another sending a text message over the shared resource. When it comes to devices, say it could be a smart meter attempting to send data over a shared network, and another data path could be used to control a traffic light in a smart city system. Example systems are communication satellite and mobile communication. Some interesting facts about FDM and FDMA. Think of FDM as precursor to FDMA. That is, when single frequency for communication started posing problems, frequency division multiplexing turned out to be the solution. This is because spectrum was limited while users and applications per user were numerous. Now, you can imagine FDM as a concept while FDMA is a practical application or implementation of this FDM concept. Modern systems like cellular, Wi-Fi, satellite communication all use FDM concept. Let us take an example of communication satellites. In case of communication satellites, if one segment or a chunk of frequency is affected due to a selective frequency loss in the environment because of interference, another segment of the frequency could be used. Also, it could be used in cases of diversity. Similarly, communication satellites also cater to multiple users using FDM concept. Consider also example of cellular communication, where inherently the concept of FDM is to support multiple users and multiple applications. So FDM is used in OFDM, which is a popular waveform used in 4G and 5G for multi-user communication. Finally, in both these cases, FDD or duplexing is assumed in both satellite and cellular communication since communication happens in both directions.
Please click on like and subscribe to our channel and click on the bell icon for regular updates.